All right, hey, welcome back to Programming Through Mobile App Development. This is HTML Basics and Refresher. So what we're going to be going through today is a, a layout of what HTML actually is, the language we're going to be using here, some basics on writing HTML, and then we're going to talk about a little bit under the hood of what your browser is actually doing with HTML when we talk about the DOM, and a handful of HTML tips. And these are sort of general purpose things, but as you start writing HTML, I want these tips kind of, primed in your brain. So, okay, let's dive right in. So we're trying to get acquainted with HTML, right? And this is just one of the three languages we're going to touch on in this course in all of web dev, right? And toward the goal of building some kind of app. So before we get into that genuine kind of programming and app building stuff, we got to pin down the fundamental parts of what those programs are going to use, right? If you've ever messed with programming before, this would be like learning what your basic, numbers and variables are. But in this case, we're not dealing just with the abstract concepts of numbers and strings. We're dealing with more concrete objects in the HTML world. So the idea that I'm using a metaphor here, putting all this another way. If your program is a play that your computer needs to execute, then where you are giving the instructions to actors to perform actions, right? A lot of talking, a lot of stage direction, telling what to wear and all that. You're going to be using props, costumes, and decor as well in this play, right? So it would be good to know about the actors and the props that are available to you, the director, right? So that's what HTML's role is in this sort of triumvirate, is create the objects, create the materials, the props, the scenery, the stage, everything about, what am I actually going to be using in this program? So what is HTML? And why does it make such boring looking websites? So HTML alone, this is a hypertext markup language. So it's the basic language of web page content. Any HTML file, similar to any code, is essentially just a simple text file saved with the .html file extension instead of .txt, right? Where the content is mostly just HTML tags and text, and such that it's readable by a web browser, right? So the language itself is hypertext, as in more than just text, and markup, as in the way raw text is formatted. Think about like how things are organized in a Word document. That's the idea of markup, indent here, carriage return here, line spacing, that kind of stuff. So let's pull these apart a little bit further. Markup languages, these are the kinds of languages that exist to define the structure of information and documents. So it's just any language that is designed to define structure, and information obviously is the basic currency of any language, but defining structure, right? So if you learn HTML, you are learning one of a slew of other document markup languages, like Markdown is a huge one. It's got a super simple syntax, and it's very useful for setting up, scratching out notes that then make nice, pretty pages later. LaTeX, you may have heard of. This is the one that generates academic article-esque documents, right? So you write LaTeX, the code, and it will it will print out a PDF of your document that looks very much like, say, a journal article, right? Another markup language that is super useful, that's beyond just those sort of specific examples, is XML. And that's a little less about specifically documents. It's still a markup language, but it's about all kinds of structure of data, right? So, for example, modern Word documents use XML. That's what that .x at the end of docx means, right? So this tiny example here on the side this is an XML definition of a recipe, right? So if I'm going to define a recipe, what properties will it have? What elements will a recipe have? In this case, you got the title is peanut butter on a spoon. Very simple recipe sounds like, and indeed it is. So now we open up the ingredient list and we say, okay, here's an ingredient, peanut butter, and the ingredient list. Open up the preparation. So these are the elements that all recipes kind of have in common, right? You always have some kind of name. You always have some kind of list of ingredients. You always have some method of preparation. And that can be structured in this way. So that's the idea of a markup language. It's a way of structuring information that makes it more usable. And I hope you can see here kind of intuitively that this is also a little bit better for a computer, right? It's very defined. Recipes have titles, ingredient lists, and preparations, and the computer will then know what to do with that information if I'm going to define a new recipe for it. Okay, now hypertext. What does hypertext mean? More than just text. So hyper just always means more than, right? But why was this such a key thing? The concept of hypertext is that text displayed isn't just text. The documents aren't just text. It can also contain metadata, right? It has a wide variety of options for color, font, animation, all that kind of fun stuff. And it also can bring in outside information, multimedia type things like images. And more than all of those is that text can link to other text. That is the key thing with hypertext. That's what made this whole friggin' language take off, is that you can connect text right there in the text to other information. So that linking, that turns a simple linear pile of text into a knowledge base, right? This idea of having a link structure that's easily navigable by a human is very, very useful. So, quick discussion of just what do I mean when I say knowledge base? Well, this is the difference between a flat text encyclopedia and Wikipedia, right? So, it really can't understate how important it is that you are able in hypertext world to link quickly between documents, right? So, before this kind of link structure was possible, information was just stored linearly, right? As in you had to either read through the whole book to find the information you're looking for, or know how to navigate and make use of the indexes, writing down the keywords and the references to find later, right? The ability to just click a link brings all of that search that used to be such a big job. You know, librarians used to do this all the time for people. You'd be like, hey, can you help me find 2 books on blah, blah, blah? Now it's a knowledge base, right, that you can navigate directly. So I interrupted myself. The information relevant to your current situation, you can keep it front of mind, right? While you are navigating a page, you can think, okay, well, I need to go to this part of this website or this part of my app or whatever. You keep links all together in the places where they're relevant to what you're actually currently reading. So this idea, I refer to this, and in the cognitive world, you use this sometimes. It allows you to continue, the user can keep using and searching and navigating topics and or parts of an app at the speed of thought, right? When the relevant stuff is right here and I'm actively perusing the information on a page and I can just click to the next thing that I need, that's great. You know, everything is still fresh. You're not forgetting things. You're not leaving things on the table. So let's look at an example we've seen before, the capybara article on Wikipedia. Let's do a quick rundown of how many links are here. You know, if you just scan it, you'll see, holy crap, look at all the blue text, right? Look at how much hypertext is present in just this one paragraph and a couple of boxes here. So the first paragraph alone contains 14 links to related wiki pages within this same wiki, for like places and other relevant information, anything that might be of interest to you while you are learning of the capybara. You can now jump around to things like, oh, this is where they're from. Oh, this is their nearest neighbor, right? There's 2 links to external documented sources, right? So we're going beyond just the website itself, and we're going outside for some evidence. There's 1 link to a single side note about the capybara in the note 1. I'm not sure what it says. I didn't scroll down to find out, but that's on this document. But it's hypertext within this one document, right? It's a linkable, jumpable piece of this page. On the sidebar, we have 10 links to other concept pages, including all the kingdom, phylum, class, etc. of the capybara, but also, other stuff. 2 links to external sources again. And in the contents box, we're chock full of links to other locations within just this document, right? So these links, these hypertext links, are allowing us to jump outside of the website, jump to another page on the website, or jump to another part of this page itself, right? So now I just want you to imagine trying to find any of this stuff if you had to look it up manually, right? It's possible, right? The old way of going to the library and looking at encyclopedias and volumes and stuff and finding a way to navigate their card systems and their Dewey Decimal System and all that stuff, it exists, right? But it was slow. It took a lot of time. That was your whole afternoon, right? And so by bringing everything into the fold right here while you are using it, that's the value of hypertext. So what is HTML in theory, right? We're not even to the coding part yet. I just want you to understand what this language is for, right? So what is HTML? It's a language that, at its inception, unified the concepts of structuring documents using markup and connecting documents in this very brain-friendly way using links between those documents. So it provides this tight way to both construct and connect information, which is exactly what the internet needed to get started, right? So that's the kind of the story of HTML is, hey, I want to have a whole bunch of things in this nebulous network of the World Wide Web, it used to be called. And we still sort of call it that. It's not really, I don't know. Internet is the only name that really stuck. So yeah. Now, quick aside. We keep talking about the internet. Why am I talking about internet properties and internet languages and stuff? Where's the app in all of this? So that's a valid question. So hey, we're spending a lot of time talking about the dang internet. What if I just want to make an app for scheduling quality feeding time with my extensive turtle collection? Well, first of all, cool. Show me your turtles. I want to learn all about your turtle collection, and I want to support you in building your app to help you facilitate your life with your turtle collection. But the key thing here is about what the internet and apps all share, is that they are informational entities that involve human users who navigate information, right? They involve structuring and connecting information in a way that humans can use it. And the more you understand the structure of the language that underlies something like the internet, you'll better fundamentally understand the other. And I'll even go as far as to say, beyond the text here, the internet is one gigantic app. If you want to slice the lines and define it in that broad of a way, you could, because it's one gigantic set of stuff happening somewhere with a lot of moving parts that you have a human interface to, right? Your web browser connects you to the whole of the internet in that way. So that's the idea. Understanding how the internet is connected with these structural languages will help you understand how an app can be built with these structural languages. Okay, so that's the idea. That's what HTML is. I hope that's sort of sticking in your mind. Now let's talk about writing HTML. What exactly can we do with this language? And the answer is, well, on its own, not a whole lot that's interesting, but lots of basics. So, HTML element tags. How do you actually write this stuff? And how do we build a tag? So, as we talked about just now, the markup part of HTML is all about structure. So in HTML, you nest text and other information in element tags. And the basic way you do that is you open a tag. So like bracket P, bracket. You give that tag some sort of content. So usually some kind of text string or potentially another tag. And then you close that tag. And that is itself a simple HTML element, right? The browser then takes this and interprets it as, okay, line by line, P, Okay, I'm going to create a paragraph element. Hello. Okay, I'll put the string hello into that element. And then /p. Okay, I'm going to stop adding things to that paragraph element, and I'll move on and parse something else, right? So when you write p hello /p in this way, you create a paragraph object in the browser. So let's do a little walkthrough of a very simple site. At the top of the HTML file, you would typically have something like this. You're telling, hey, what kind of markup language are we using in HTML here? Okay, so we open an HTML object. We open the head, and we can define the title, which appears anytime you go to a web page and there's like a name in the tab, that's the title object, right? And that happens inside of the head section of your HTML file. Okay, and then we open up the body section, okay? And we go through, here's H1, an index, okay, cool. So this is a header. This is a header object it's large text, visible, easy to read, easy for your eyes to land on it, that kind of stuff. And then P, paragraph, this is one. Okay, cool. And then we close the body, and then we close HTML. This is a site, right? Or well, a page. And let's just highlight to make sure it's clear, really connect the dots here. The title in the head up there is up there on the page. The header is defined there, and the paragraph text is defined there. We are essentially seeing where the browser has taken the information we fed in the HTML script and put here onto it, how it processes it and puts it onto the web browser, right? So let's talk about what kinds of tags are available. This isn't going to be all of them. There's a huge list available on W3 Schools or lots of places online, but that's my favorite so far. We'll talk about that later. But let's look at a few of the simple element tags and what's different about each one of them. I'll cover them quickly here, but then we'll go into depth on each one. So H1 through H6, these are headers of different sizes. So you want to have a large header, you might want to have a slightly smaller header, that kind of stuff. Basic stuff like you might do in a Word document, right? P is for paragraphs of text. Long form text is stored in the P paragraph objects. A stands for anchors, which are also known as links. We'll talk about those, which is, again, remember this part is the key thing that makes this really, really useful hypertext for the online world. ULOL and LI, so this is lists with either unordered listing or ordered listing and the items of that list. Tables, even more complex. So tables have headings, they have rows, they have individual table data. And then also multimedia stuff. So image, video, audio. These are ways you can import multimedia stuff into a document. And now you might start to recognize how, oh, shoot, if I can just import a video into one of these pages, suddenly it doesn't seem as wild about how YouTube is constructed. Because at the top, it's just a video object, and then there's a bunch of text below it, right? Okay, so before we jump into what each of these tags do, I want to introduce you, which I'll be doing this repeatedly, but introduce you again to the inspector in your web browser. So to show off some of the tags mentioned, I'm going to use the browser's inspector. It's a fundamental tool for web development. It's a way to sort of pop open the hood and see what's going on in the browser, right? So above and beyond the HTML code that we feed it. So here is the inspector for that simple page that we were just looking at, right? And the idea here is that it's able to dig into the objects that the browser is creating, right? And even more than that, again, we will be using the inspector quite a lot. But the basic version, when you're on the Elements tab of the inspector, is, hey, look, this looks quite a lot like the HTML code I just wrote. That's how the browser will show you what's going on here. You see that the head is collapsed, and you see that body is open, and we see both of our H1 and P tags. Okay, so here's the normal web browser, and here the way you would get to the inspector is you can right-click anywhere on the page and click the inspect that pops up in the context menu. You can usually get at it through the menu in Chrome. That would be View, Developer, Inspect Elements. Or you can use the keyboard shortcut On Mac, it would be Command Option I for Chrome on Mac, but you can search for what the keyboard shortcut is on your system. And what that does is pops it up like this. So we have the web page still there on the left, but now a chunk of the browser is taken up by this inspector panel. This is one of your best friends. I want to say that repeatedly, that this is one of the coolest tools for programming, is that it gives you access to so much information about any web page that you're looking at, including your own, but also including any web page, right? You can go to any page and pop the inspector open and dig around, see what they're doing, see how they build their web pages. Okay, and to illustrate all of the examples, this is the more robust example I'm using, is a stupid little web page that I made that has all these elements in it. So we can see right here, right away, oh crap, so we got headers, we got lists, we got all kinds of stuff here. We have a picture of my cat again. So this is the page we'll be using, and this is sort of the format we'll use. So let's talk about each one of these in turn. H1 through H6. I'm only highlighting the first one there. So these are headers. Headers are for drawing attention and breaking up the scene. So they help catch the reader's eye and help serve as landmarks, right? So it's really easy to notice the start of a section called links if it's there in huge lettering. If it was just the word links with a paragraph of unbroken rows, just link after link after link, that's not useful for the human eye, right? So there are 6 default sizes. So H1 is the largest and H6 is the smallest. But you can ultimately customize those and use them in whatever way you want, right? You could redefine all of these later. We'll talk about all that, but this is the basic idea. And also something to notice, while we have the inspector up, if you click on one of the elements in the inspector, you can then see it sort of highlighted within the document, right? We see that the area of the text is there in blue, so that's the actual like dimensions of the header object. But you can also see that it has some margins above and below. That's all defined by the browser, and again, we will cover all this in the future. But just it's really nice to see it, to recognize that there is overlapping space that exists between these objects. Okay, so that's headers. You use headers to, you can see right here on the page how it's easy to jump between sections with your eyes, right? Headers are good for catching the attention. Paragraphs. Now, sometimes something has to hold all of the long form text you might want to have in your system, in your tool, in your app, in whatever, right? This would be on a simple app. You might have an About Me page, or you might have an instruction manual included in the tool or whatever. You want to have a way to store paragraphs of information. So here is the simple paragraph here. You see it again. There's the text area in blue, and the orange surrounding it is the margins. So this is the basic way to present readable text to your user. This is where they will spend time reading something, yes, and it has some amount of padding above and below to help. I went a little too far. We'll keep that in. I won't even edit it. So, paragraph. It's essentially anytime you want to dump text that you have written into a web page, this is usually the default, right? Okay, moving on to links, anchors. The A tag is the anchor tag, which is another name for link, and it's allows you to connect your own site together or connect your site to something else, right? You may want to have links to the outside world. And again, anytime I talk about site, you can also think of it as app, essentially your usable thing, right? And so many apps have different tabs, every time that you click on your profile, right? Or to change something about your settings, right? Every app has multiple different sub pages. Not every, I shouldn't say every, but many apps have at least one or two different sub pages. So links. We're doing links. This is primarily what makes this hypertext. And we know the basics. You click the link and it opens to a new page. Yes, new information. In this case, we have it at somethingelse.html. Links, you might notice right away here that it is nested within the other information. It is nested within the paragraph tag. So the paragraph element has another paragraph, but with the string. It has the anchor tag, which has, we'll talk about in a moment. And then it has init, right? So that's two strings with an anchor tag between them. On the page, it just looks like unbroken text, and that's exactly what we want. But in this case, that's how the link is structured, and you see it appears right there in the main line. Okay, so links use our first attribute. So when you define a tag, you are allowed to specify attributes with it. In this case, you open the A tag, and we use the href attribute. And so if you wanted to have the link go to something else.html, you would have A, and then the link text, and then end A. And when you define A, the A tag here, you also define right next to it, separated by a space, href equals, and then the name of the page that it should look for. And this is the file system, right? The file, something else.html, is here, right? Okay. Unordered lists, ordered lists, and list items. So this is lists. It's for light organization and like ordered steps, right? So this helps organize and break up related information so that it doesn't all run together, right? If everything was stored in a paragraph, imagine if I had written all of these slides all as just an unbroken transcript of the words I'm planning to say. That's a lot. That's just a long form book, right? It doesn't help you highlight the important points. So lists are our first inherently nested structure, right? So to build a list properly, and this is for both ordered and unordered. Ordered lists have numbers for their bullets. Unordered lists have bullets for their bullets. So when you open one of these tags, here, look here on the right, we see our OL, our ordered list. It has two list items within it. So when you pick what kind of list you're using, you open that tag up, and then before you close that tag, within that tag, you have list items, so LI. And you open those, and you include information on each one, and you keep moving, right? So this one has two lines. One is an ordered list item, and the other one is another, period. You can also nest lists within lists within lists within lists if you want, like, to do an outline, right, with sub lists. That's just how you do it. Let's zoom in a little bit, though, and show off each little chunk of this. So here's the main ordered list, right? It's the whole thing. We see it has two sections. We have one section for the bullets and one section for the text, and then the padding above and below. We have a list item object. Okay, cool. So this is a list item, and it contains that text and ordered list item. Over here we have the marker of the list item. And you see it's stored next to the list item, right? It's the marker portion. In an unordered list, this would be a bullet point, but in this ordered list, it's the one with the period. And then we have the text of it, right? So this is the nested structure. We have an ordered list that contains a list item, which on its own, it auto-generates the rest of this. We don't define the marker usually. I think we are able to, but we don't typically end up doing that for an ordered list. We just want the numbers. But yeah, so this is a nested structure. When you write one of these, you nest everything within them. Yeah, so continuing on, covering table. Tables are for more heavily structured information that might need both rows and columns. So information that requires a lot of structure, like so rows of data for different things that you want to contrast. And each of those things might have various properties that you want to define at the top, right? You've all seen tables, yes? So to build one of these, it's a lot of nesting, and it's linear, but just bear with it, because we're trying to collapse a 2D thing into a vertical scroll. We'll see how it's structured here. So you can see on the right side. Well, let me do it on the left first, and then we'll talk about the right side. So you start with a table tag that says, "Hey, I'm going to build a two-dimensional text field, not text, but a two-dimensional set of items that are all going to be equally spaced and such." Then you would create a table row for each row of things you want in the table. So within each of those rows, you can have, at your discretion, you can pick either. This can be a header item, which will be sent by default. It'll be centered and bolded and all that. You can see the columns are all table header items. And then you could also have it be a data item. So things that aren't the header. So in this case, row 1, item 1, etc. Now on the right-hand side, we see that the T body is there too. You can explicitly define that, but it's also, you don't need to. The browser will automatically generate table body segments. That's one of those give or take. It's useful in some lights, but mostly for advanced purposes. So, so this is the basic way. And we see on the right here, okay, this is a vertical. Okay, let's kind of parse this out a little bit. There's the table, which contains a table body, and then that contains let's see, it is 3. One of them is currently collapsed. 3 rows. One TR has the table headers, column 1, column 2, and column 3. The next TR has the first row of stuff, each with table data. So row 1, item 1, row 1, item 2. And then the third one would have similar, right? Let's really break it out, and just so that it's clear. So you would define the table object, which is the whole thing. It automatically generates the table body segment. And then you would have 3 different rows defined, yes. So we have the top row, the middle row, and the bottom row. And within each of those, we would have table headers, table data, and table data. And that's all of it. And we're sort of highlighting each piece of it, right? And that, I hope that just shows you, this is all nested objects. Right? There's a table, but that table contains rows, and those rows contain items. Okay, let's move on to images, video, and audio. These are the media tags for embedding non-text information, right? This is another huge benefit of working with hypertext in this language, is that you can include media beyond just text, right? In fact, this is one of the key things that turns this language from a sort of boring text website builder into, these are just things I can move around. Interesting. So you can insert images with the image tag in the document, and they can be anywhere. They can be embedded in other elements. You can kind of jam them into paragraphs, although that can go kind of strange. The image that I've defined here has 2 relevant attributes, right? We talked about attributes with the anchor tag. The image tag has 2 important attributes that I've included here. One is the source, very similar to the href in the anchor tag. And this is where you're going to define, hey, what file? Hey, I'm a computer. I'm a web server piece of software. What file should I send to the person who loads this page, right? And that's what this does. The image object retrieves the file location of the image. We also want to be able to define very simply the width, right? So this image is actually huge. If I included it on the page normally, it would be 1,000 pixels tall or something. So I set the width a little bit smaller so it would fit in this page. That's just barely on the edges of tinkering with the internal stuff here, but it's an important basic thing to do. So image tags allow you to pull this stuff in. We can also do it with video and audio, and there's tons of others, right? Multimedia is really the name of the game with these things. You can embed all kinds of multimedia stuff into one of these pages. Let's quickly discuss the idea of containers. So we've seen a bunch of these are the kind of fundamental elements of certain kinds of text and ordering text and arranging text and some multimedia stuff, right? some tags are less about specific elements and they're more about containing and organizing other elements. So HTML, head, body, those are all tags we've seen already, but they don't really do a whole lot, right? They don't seem like they're building anything specific or interesting for our eyes to look at. That's because they are structural, right, for the page itself. And real quick too, element tags can also all be nested within each other. They can contain other element tags. So you could have a 3x3 table that's full of both either paragraphs, or they could all be videos or images or whatever you want, right? You could also have a list where each list item is a whole paragraph, right? Kind of whatever you want to do, however you want to structure these elements together, you can do that. But some tags are essentially only exist as containers, right? It's not like the body doesn't have a real presence on the page. It's just the thing that contains everything else. So, for example, the HTML tag that's what defines for the system reading your HTML file. Oh, here's where all the stuff is. If you have anything outside of that tag, the browser won't even consider it. It'll just be like, oh, that's not relevant, right? So the HTML tag is a container for everything that the document is. And within that, you have the head tag, which is where you put metadata about the page, right? Links to other things you're pulling in, like JavaScript files or CSS files, things that aren't rendered within the browser, apart from the title tag that you can do there. The body tag, though, is anything you do want in the browser window. So that's where all the stuff appears. And then one last one that I just want to bring up. We're not going to focus on it right now, but it will become more important as we keep going. The div tag, which just stands for division. It's for sections. So the idea being that you're not just going to pile a bunch of paragraph tags into a site and be done with it, right? Really, you're going to be organizing things in sections that are meaningful and connected, right? So you would have divs for all your different elements and panels and combinations of things, right? We're thinking in terms of collections, connecting things together. So again, these are going to come up in the future. They're super powerful, and they're very flexible, but for now, we'll just talk about them. They exist. These are containing tags. And real quick, just to show what the inspector shows when you highlight your HTML tag, is the entire thing, right? It's everything that exists in the browser is there. The body tag does have some properties. It has a little bit of borders and padding that we can see. And those you can change, right? You can change the properties of the body tag to change a little bit about how the whole site is rendered. The most basic one would be, color, right? But again, that's for next time. That's for CSS. Okay, so writing HTML. How do we do that? Here's the recap. So we've talked about plenty of stuff in this section. Really, we focused on a lot of the basic elements that you can use to create HTML objects, right? There's a few basic types of structure available in these tags. We have headers and paragraphs for text content. We have lists and tables for more structured text content, not just the basics. We have multimedia for the non-text content out there. And then we have links for connecting page views to other pages. We saw a little bit of how containers exist and are something good to keep in mind. And we also used the inspector to examine a web page. And that's just the very basics, right? I want to throw a shout out to, again, W3 Schools. Each of these tags that you see here, if you go to this link, this is the reference by function. So this is grouped together all the different tags and elements available in basic HTML for things like lists, tables, but also audio, video, images, for certain programming stuff that we'll get to later. Forms and input, so some basic interactions like buttons and text input areas and that kind of stuff. And then, our super basic HTML that we've just covered. So that's that aside, continuing on, let's talk about the DOM and try to get an understanding of what's happening under the hood when the browser reads this HTML file. So after you write the HTML, but before it's displayed, something must happen. Yes? We've seen how you write some tags that causes the browser to create those elements and display them, right? We've also seen how the browser treats different tags by default. Headings have different sizes and boldness and all different properties by default than the paragraphs do. They're larger and they're denser, right? Table elements have different default padding and alignment rules than list items, right? We saw that the table elements were very tight and they were right next to each other versus the list elements that were spread out vertically, right? None of that is defined in the HTML file, right? We just had that simple text displayed. It's just flat monospace text, like all of it. But the browser still knows what to do, right? Which hints at the idea that there is something more going on than just, oh, here's flat text and these are the exact things we should do. It's doing something in that middle step. So the HTML file comes in, the browser digests it, and then the browser displays a web page. So let's zoom into that middle step. What is going on behind the scenes that allows the browser to take your simple flat text file and turn it into something readable and machine readable first and then human readable again when it builds the actual web page? So, how the web page data is structured internally in the browser. So the DOM, Document Object Model, is the model for how the document, the web page in this case, is represented in terms of data objects internally in the browser, right? Each of the tags you read in from an HTML file are turned into data objects that are connected to each other. Some are child elements, so the ones that can be nested inside the parents, like a table data inside of a table row, right? And some information is just an attribute of an element. So, for example, the href of an anchor tag is an attribute attached to that anchor. The more simple one is the text in a paragraph, right? It creates a paragraph object, and then it creates some kind of text inside that, or within a header, right? A header has a text value in there. Those are objects. These are things these are all programmatic objects that do things. So let's expand this out a little bit, because I think the ideas at play here are good to understand in a more sort of broad, fundamental way. So let's start with, what is a model, right? We've touched on this word, and it will come up again, I promise you. What does a model mean in this context? Well, we could also ask, what does a model mean in any context? So a model, in general, is a useful, simplified version of a real thing, right? For example, a model train is a small version of an actual train. Now, you might question, is that useful? Well, let's say your job was to understand how to build a train yard. You might need to have scale models of things to understand what to do, right? Similarly, you may have heard of statistical or mathematical models, scientific models. These are numerical reductions of real-world things, right? So, for example, the equation for gravity. It's a useful, simplified way to describe all behavior of gravity for falling objects using just a couple of variables and some relationships, right? Your velocity is negative 9.8 meters per second, right? Your falling velocity equals negative 9.8 meters per second, as in it accelerates as it falls, right? So using this mathematical model, this numerical, this data-based reduction, we're able to do this very cool thing of being able to predict, hey, if I drop a ball, I know roughly where it will be after n many seconds, right? So a computer is always modeling, right? That's kind of all it does, because the computer is storing information in the absolute minimum form and space possible. Electrical bits on a superconductive wafer of silicon, yeah? So in the DOM, the model refers to the data that is used to reconstruct the page for the user to view it, right? So in this world, what we're talking about here, the model is the data, right? Now, if you've ever done any other programming, you're dealing with data all the time, right? You have some kind of variable here, some kind of variable here. Those are all essentially the model, right? The data in the back end. And again, like I said, they're going to come up again in the future. Okay, now what are objects? HTML tags become HTML element objects, right? So they aren't objects in the text until they're created in the browser. So in programming world, objects are typically this intermediate level concept. It's the idea of sort of grouping together data and functions that are relevant to that data, right? In this coherent way. So, for example, consider a cat. Is it useful to think of a cat as just a billion separate tissue fibers that all happen to be in one spot? They all happen to be, just coincidentally, they are aligned together? Or is it more useful to think of a cat as a single object? And I mean that in the generic sense. I'm not calling all cat. They're not things. They're borderline people. But they are a single thing. They are a single entity that has abilities and internal states, right? In this example, we see that the cat has a sleep routine that it can call. It has a play routine that it can call. It has internal states like, am I hungry? If I'm hungry, I should go find food. If I'm bored, I should go find play. If I'm tired, I should go find sleep. These are all kinds of information that grouped together make a lot more sense as a single thing, as opposed to trying just putting together random scattered things. So it's funny because in this world, and I hope the way I've described it, it's relatively intuitive, right? I don't want to spook you, by saying, oh, this is an intermediate level concept, because it's a more human way of thinking about things, right? It's not, there happens to be a billion pieces of data and they're all there. It's which parts move together, which parts function together, right? And in HTML and all of web dev, I say it's kind of interesting because object orientation is basic. The very first thing we do is build objects that have their own properties, have their own features, have their own everything. So nothing happens on a web page without dealing with objects. So just keep in your mind that objects are the form that the data takes that you feed into the machine, and then it does a lot of things with it. And later you will learn how to change those things and manipulate those things and move and do fun things with those things. So, here's our page again. And let's do a quick example of, you can jump to, this is a little bit of JavaScript, and I'll just walk you through it. Don't worry, you're not on the hook for understanding JavaScript yet. But a little bit of JavaScript in the inspector console to grab the data object of this first H1 element, right? So the header, the one that just says first header up there, we're going to go and find its data object, not the thing that's displayed on the screen, and not even the thing that's in the elements here, but we're going to go in JavaScript world and pull that element down so we can crack it open. So I define a variable X in JavaScript, and I go and get, so document.getElement by ID first. I've given it that ID. Again, don't worry that I'm just walking you through it. So in X, now I've stored the data object of that element, that HTML element. And then I quickly do X again just to see, is it there? Did we get it? Yes, we did. We can see that the first thing it prints out is this, is just like a quick indicator of, oh yeah, that's the HTML object that you pulled out. Then if I hit X dot and I want to see, hey, what are the functions and properties and data things inside of this object? Whoo buddy, we immediately get a huge pop-up list of tons of things this object has and can do, right? So this simple header, this thing that's just like a little bit of text at the top of a page, under the hood, has so many abilities, so many things, so much data associated with it. And this is just the A's, right? So there's actually hundreds of methods and properties in this single, simple H1 element, right? So anytime you build an object using HTML, recognize that under the hood, inside the DOM, in the document object model, it has boatloads of features and things. You're not responsible for learning all of those things. Even if you become a professional web developer, you don't need to memorize this list. The point is that these things exist, and if you know how to find them, you can use them, right? So let's walk through our simple example again, and look at. So we have the HTML code over here, our simple index, and then we have the browser window over here. We know this part, right? We know that when I load in the code on the left, the browser window will look like this on the end. Let's look at how the DOM is constructed though. So here comes the DOM elements. So first thing read in by the parser is the HTML tag. Okay, I'll build an HTML object. Great. Okay, body. Great. I will put a body object inside of the HTML. Great. Okay, now I'll build a header. Right? Okay, great. I can do that as well. Oh, so you've got some text. Let me go ahead and define the text as you've given it to me. But the thing that I want to kind of highlight here is that that's all the stuff that we've told it to do. It also does a boatload of other stuff just automatically, right? It defines the margins. It defines the font size for the header. It defines the weight of the header, so the boldness and the font, all those things that we saw just now, right, in the data version of the header object, they get set to some default, right? So again, the DOM is the programmatic side of parsing your HTML, and it's doing a lot of work. And later on, we learn how to do that same kind of work. So paragraph, do the same thing. Here's the text of it, but again, I'm going to automatically build that stuff, and then we close it all out and we go on. That's essentially how the DOM is responsible for catching the HTML code that we write and then building something internally that is, again, it's the model, right? This is the model of the document that wants to be printed to the screen. This is the data. This is the back end. And then it brings it all to the front end. It says, so I'm gonna now dump all this out into your browser, and I'm gonna display it in the way that I know how to display it. Okay, so that's the DOM, the document object model. Let's recap real quick. So the document object model is the model for how to represent a document using data objects that is used by the browser. Every tag you make in HTML is first converted into an object and given some default properties, and then it's stored in the DOM. Then the browser looks at every single object in the DOM and draws it, right? It doesn't need to look at your original file anymore. It's already loaded it all into data that it's better at using, right? So why do we care about this thing, right? Why am I complicating the story when we could just have HTML that comes to a web page? Well, going forward, this is all that we deal with, right? Both CSS and JavaScript are primarily, their primary function is to alter properties of the objects in the DOM, right? CSS does them up front when the page loads, but JavaScript does them on the fly while the page is active, right? And you can do things on the page. So by altering those properties, we change how they're displayed to the user, and that ends up being what we're doing here, right? We are building an app. Apps inherently respond to user interactions, meaning we have to change things. So that's the goal. That's the idea. And that's why this, understanding the DOM, is super useful for you going forward. Okay, what else is super useful for you going forward? A slew of HTML tips. So let's get into some. This is just some thoughts I have on working with HTML effectively. So one really cool thing about working in web dev languages and web browsers and such is that debugging is so much more intuitive. You can do it both visually, but also you have the power of the inspector with you. So one of the very best parts here is it's all super visual, meaning when you muck around and change the model in the data, you're going to notice those changes in the browser window, right? Because everything we're doing is about sort of the view, the visual side of things. It's very easy to detect when things are like a little bit off. So it's good to keep opening and refreshing your web page as you work on it. You get this instant feedback and you can quickly suss out like, hey, that's perfect. I did it. Yay. Or, oh, that shouldn't be happening. What did I do wrong? That kind of stuff. You learn a lot just from interacting with the tool, right, in this way. And on top of that, the inspector is just jam-packed with all kinds of information about the DOM, the code, execution, all that good stuff. One could do an entire course on just the inspector tool. We won't be, but it's great. So visually bugging in the inspector and like the interacting, when you start writing a page, you can be your own best guess and checker, right? Another tool that's great and is available to you is W3 Schools. This incredible website. It's chock full of tutorials, references, live demos. It's a whole bunch of things for HTML, JavaScript, and CSS, but it's also got other languages, right? If you ever get curious about Python, that's a decent place to start, because the very best thing about this site is that, it's actually an app. It's an interactive site, and I think of it as a living textbook. It has references for everything, right? So if you're like, what are the properties of this tag? You can just look things up. But it also has in-browser demos and examples that you can play with on the site. So you can see, that's how that works. And you're able to change things within the site itself and just like, okay, let me change this example. And really, really, really get in your head, okay, I understand how this tag works. I understand how changing it works. I understand how breaking it works, right? So you can learn a lot just from playing around on the site, It's a great tool in your belt. So keep W3 Schools in mind. If you ever find yourself a little bit confused about the way something is functioning, start there. Okay. HTML is very lenient, and that's not always a great thing. Let's say you're in a hurry and you forgot to close a bunch of tags. I wouldn't advise you be in that much of a hurry while you're writing code, but it happens, right? So here's the thing. HTML is usually cool with that. It's like, fine, I don't care if you close your tags. I'll figure it out. So that's what it does. It tries its best to figure out what you mean if you leave in some slightly broken HTML code. It's meant to help with general accessibility, right? So people making websites aren't perfect programmers, and we don't necessarily want them to all have to be, right? I mean, building a web element is supposed to be a basic function of the internet. So it's nice for that sake of not having all these completely broken, unloadable sites everywhere just because somebody forgot a few closing tags or something. And it's also good for users who are trying to read those sites, right? Like, we don't want a site to throw up a million errors and not be viewable for a user, right? But I hope you can recognize that this can bite you, right? Because while the parser is doing its best to figure out what the heck you were trying to do when you left things half broken, it will do it in ways that you may not be able to predict, right? Especially if the problem in the first place is that you were, I didn't fully understand, I should have closed that. So what it figures out might not really be what you're trying to do, right? So making a proper, try making an OL, ordered list object, but then after making some list items, delete all the closing tags for the list items. That should work fine. But try making a nested OL where you have a few different nested lists within lists and don't close any of those lists. Things get messy really quick and it screws up the whole page. So yeah, that's just a tip. So in general, try to make sure you close your tags properly. That's like super basic diligence. But on top of that, just pay attention to the conventions and try and do your best to not just get comfortable with the idea that, the page loads, that should be fine, right? Because the real trouble here is that HTML will fail silently. Where other languages might explode when you try to run bad code, HTML will quietly just do its best. And that can be a real problem for the way that you structure things. So just keep this in mind. You will guaranteed make an error that HTML doesn't tell you about at some point, right? That's okay. That's life. That's how you do this. Okay, white space and how to use it. Fact one, the browser does not care about the empty spaces or white space in your code, right? We're talking about tabs, new lines, spaces themselves, that kind of stuff. Fact two, your brain does. And so does any other brain that you ever read code, that reads your code. So In general, here's the idea. Try to use new lines and tabs and spaces to keep your code visually decently organized and uncluttered. Now, what exactly does that mean? Well, it's kind of up to your taste in a sense. You don't have to do everything exactly the same way, but a couple of things that are good to focus on, right? You should signify nested structure with indentation, right? If my H1 is contained within the body tag, then the H1 should be indented relative to that body tag. And then also signify the separation of concepts using blank new lines, right? So if an H1 tag and a P tag are right next to each other in the code, it's good to give them a little breathing room, right? So just as we've been talking about objects, right? Well, your eyes also see objects, right? So you can see over here how I have sort of a visual, it's easy to visually see where things are. So just remember that just because your code functions doesn't mean it'll be easy for someone else to read, including your future self. There's only one thing programmers hate more than reading other people's code. It's reading their own code from 6 months ago. You will say such mean things about your past self when you start to program, and your eyes will thank you. I also just want to highlight here. I mean, think about this: the empty space I have here. Mine's a little bit excessive, right? You could probably have some of these things on the same line, like the title, the H1, that kind of stuff. But you can see how things are organized, right? Over here on the right, I'll draw a bunch of lines to show, okay, here's the segmentation based on the new lines, and here's the segmentation based on the indentations, right? You can see sort of quickly, now, the color obviously helps here, but I'm just trying to illustrate that the separations on the left side kind of imply the visuals on the right. So just keep this stuff in mind. Also, let's jump through a few examples. So this is the basic code of one of these things, right? This works, right? This is the document we've just looked at. This is the index with the title and the head, and also the body with the header tag and the paragraph tag, right? This is the same file, according to the browser, right? It's not bad, right? It's a little tight. Like you can still see what's going on. The indentation helps a lot. I've done this thing that a lot of folks do, which is having the tags just on their own lines. That's a viable option. I would say this one is okay, right? This is tight as long as your code isn't too complex and you're not doing too many things that are, cluttering things up and having super long lines and stuff. Here's another one that works identically. This is the same page. This is the same page. This is the same page. Right? All of these are the same web page according to the DOM and the browser. They don't care about the white space. But my question to you is, which one of these is easiest for you to read and make sense of the page's structure? White space, when you're first getting started, it seems so laborious. So, oh my God, so annoying. I have to say all these typing, spaces, all this time organizing. Well, you better, right? You need to organize your stuff. Otherwise, you're going to get stuck with something that is borderline unreadable by you. And that's not great for programming. So for me, I'm going to stick to doing it in the left-hand style just because that'll be the most obvious for when I communicate with y'all. But somewhere between that and the second one right there, right? As long as you've got some good indentation and good sectioning, just be aware, right? Next, we should talk about commenting, leaving yourself and others some documentation. So sometimes you want to write something in code file that's just for you or other human readers, not the computer. You don't want the computer to read this thing. I just want to leave a bit of information here so that me or whoever else is reading this can make sense of it, right? So here's a lot of examples of why you might want to leave a comment. When some of your code doesn't make a lot of sense on the surface reading and you want to explain a little bit, like, okay, these next 10 lines do this together, right? Meta notes about whether something is working. So if you're actively working on a project and you want to leave some notes about like, okay, this thing functions, but it's a little bit messed up, I'm not sure why. Like, Writing small to-do lists right there in the code file, right? A to-do list is great if you have it stored somewhere, but it's even better if it's just like right here in the file that you're working on. Or even better is you can switch off some code, right? If I take a set of code that I want to just kind of remove from the document, I can just comment it out instead of deleting it, because then it's still there, but the computer will now ignore it, right? So this is just like the whole idea. This is why you want to comment stuff sometimes. It's called commenting, and it functions slightly different in every language. In HTML specifically, you can use this comment tag, which puts everything in one gigantic tag like this. It is a bracket, exclamation point, dash, dash. Everything from there until the next time it sees the dash, dash, end bracket, that will be ignored by the parser, right? So, for example, here's our document again, and here it is with a bunch of comments in it, right? At the top, I put a little to-do list. Under HTML, I disabled head by putting one, the opening comment there above it and the end comment symbol below it. Down in the body, I put a little note. I should add some more links here, whatever. This is a slightly documented file. This is a file that is now, that has comments in it. And the final tip, and this will come up a lot from me, remember that it's all just text. Every code file ever started as a blank text file. So the reason I say this, it gets a little daunting to think, oh man, look at all these websites. They all have so many lines of code. And I'm supposed to understand all of this. I'm supposed to write this. Like, no, right? Every code file is just a bunch of text. And the more you learn about what each line of code does in whatever language you're working in, the more you realize it all just makes a certain basic kind of sense. It's all about logic and learning what that logic is. And there's never any magic, right? It's just a lot of simple elements coming together to make something more complex. So whenever you sit down to start writing some HTML from a blank file, remember, it's all doable. It's all, somebody else has done the same process that you are now starting, right? Okay, so recap on the tips. You get a lot of mileage out of checking your file in the browser, just like visually checking it out, but also digging deeper using the inspector, right? If that's not enough, the W3 Schools site is super great. It's full of educational and reference content for web dev languages and other languages. HTML is extremely lenient for better and worse, so be careful. Just because your page doesn't outright explode when you try to load it doesn't mean it's not doing something weird. Just be careful, close your tags, and just keep this in mind, right? If something breaks, think of this as one thing that, oh, maybe I missed something simple, right? Use white space to keep your code looking decently well organized to your eyeballs, and use comments to add just for humans information to your code and for yourself, for others and yourself, right? And finally, remember that it's all just text. Every web page and app used to be an empty text file, and every line does something that you can learn, right? So that's our HTML basics and refresher. Let's recap real quick what we covered today. HTML is a hypertext markup language, meaning it's both more than just text, and it defines the properties of the document. There are loads of tags in HTML that do different things in the browser. Combining these different basic tags is essentially how every web page is fundamentally constructed. The DOM, the document object model, is how the definition of your web page is stored internally as data by the browser after reading your HTML file, and that it later uses that to render the documents to the browser window. And finally, remember that if you're ever stuck, there are loads of resources available from the browser inspector to the W3 school sites and advice guides and me, right? That's my role here. So, as usual for a lecture, I'm going to leave you with a final thought. Go to any web page you're used to visiting, or just the school site if you can't think of one. Pop open your browser's inspector on that page. In the Elements tab, hover over the various elements and see where they're located and how they're used on the page. Is the way they're using the element tag straightforward? Surprising? A mix? All right, that's it. Take care.